architecture offers. Let us see an example now. The user is watching a match where a free kick, for example, is about to take place. In parallel, in another match for which the user has expressed interest in his personal profile, a goal attempt has just taken place. In this case, his PDA device receives the related information and displays it. While since the event is important, it automatically switches to the corresponding channel unless the user decides to opt out. Regarding the implementation, there are three main parts. First of all, there's a web service implemented using the Microsoft WCF platform and hosted in an IEEE server. Then the user interface of the web service, in which the user creates his profile and is able to set the metadata and the recommendations, implemented in two versions. The one over the Silverlight platform from Microsoft, and one using plain HTML and JavaScript. The third part is the application used to support the channel switching, implemented in Windows Mobile. Let's describe the use case scenario now. This scenario features the parallel viewing of two soccer matches where the platform is used in order to provide the user with the capability to follow both matches, while he is informed about the most important events, and whenever something important happens in one match, the TV channel is switched so that the user is able to watch it. During the login procedure, the user enters his username and password in the corresponding boxes and then continues with the registration of his sport event viewing preferences. In this way, he creates his profile. This was made possible through the use of a web server acting as a front end to the user preferences repository. Due to the fact that this specific scenario is related to soccer games, users' profiles are going to be formed by marking their favorite events as regards punishment, goals and efforts and goals, and others. Let's watch some of those in the following figure. This screenshot shows that there are 4 levels to characterize the importance that each event has for every user. It's great, so-and-so, small, or not at all. The concept is that during this soccer game, and based on the importance the user has given to each event, he will receive the corresponding annotations. For example, goals, offsides, dropped balls, throw-in, etc. The user, after marking his favorite event, has a chance to select his favorite players, which will be shown in the next figure. So, the user here ticks the box on the right of the players' names. This action means that he places the chosen players in higher level of importance than the non-chosen ones. That is, he gives priority over the remaining players. This way, any metadata or recommendations that include them are in priority. By this action, and the saving of his choices, the user completes the login procedure and the profile creation. In order to evaluate the use of the platform, we have simulated a scenario related to 2 soccer games, G1 and G2. In these games, there are 2 Greek soccer teams, HG1 and HG2, these are code names, which are competing against other European teams, EG1 and EG2, in the context of a European Cup. Kickoff is supposed to be at the same time. The match descriptions that have been used as a basis for the production of the corresponding metadata are available for free over the internet at the UEFA website. Recorded versions of the broadcast of matches over public TV in Greece were used for this evaluation scenario. So let's have a look at the simulation scenario. A viewer sits in front of his TV set on a European Cup night, having selected to watch 2 specific matches in parallel. The user has entered the website and he has chosen the list of available matches, the corresponding 2, and completed his selection by selecting particular players that he wishes to follow, as well as the importance of match events, fouls, corners, corner kicks, etc. just like the two screenshots shown in the previous slides. During the match, the user receives on the PDA screen metadata based on his preferred events and players, filtered to match his selections when profile creation was performed. In case an important event happens in match B while the user is watching match A, the user is informed about it with a notification. If the event is so important that a channel switch should take place, a corresponding recommendation appears on his PDA screen. After some seconds, and if the user takes no action, the PDA makes a channel switch on the TV. Now let's have a look at how we create the metadata. For each sport, we have created a list of events which are possible to happen. For example, for soccer, some of the possible events are the goal, the attempt for goal, the foul near the box, the foul away from the box, etc. Every event is assigned two weights, one according to the user preferences, and another one according to how important this event is. We also have the user preferences about the athletes, the teams, and the sports they like. Every metadata is formulated from the event, from the above list, so that is described, the player who is participating, the team, and the sport. All this information, all this metadata importance is evaluated using the formula that you can see, which is three multiplications and addition of all these weights, so that we create a final weight for a specific event. There are many approaches on how the annotation of an important event to the users is created. In the first approach, the creation of annotations can be made manually. This is an easy and very low-cost solution. An implementation based on manual annotation has been proposed in the project Sports Scout. The user scout can enter a specific game in this platform, for example a football or basketball game, and among other capabilities to make free commentary on the scenes. Sports Scout is already used by football and basketball sections of important Greek teams. Another solution is the use of existing information regarding the coverage of a match, such as the information already available from the UEFA Champions League site, in which there is streaming textual description of the soccer game being produced in real time. The third and state-of-the-art solution is based on real-time image and video analysis and tracking, performed through a fully automated procedure of annotation creation. All the above alternatives result in the creation of a metadata stream that is personalized for each user and is synchronized with the video before transmission. Regarding the possibilities to expand the existing platform, an important issue is the integration of logic that allows the system to become self-adaptive to the choices of the user and his reactions to the recommendations of the system. This can result in a platform that is able to make recommendations more dynamic and more adapted to the user watching behavior. Another possible extension is the display of recommendations in the form of a video window showing what is happening in the parallel event, that is picture-in-picture. This is of course only for TVs that allow it, instead of direct channel change. These are the extensions that we are currently thinking about making to the platform. This brings the presentation to the end. I would like to thank you very much for your attention.